Hi students, all of you welcome. Welcome to Sunil Engineering Academy. I am Sunil Kumar Bandaru. Students, in this chemistry, recently we have completed organic chemistry, correct? Now we are going to discuss the periodic table. Okay, periodic classification of elements. Let us start the session, guys. Yes. Now coming to periodic classification of elements. Classification of elements. Very important topic for all the competitive examinations. Student, just opening video and skipping video means you may not get anything. Okay. If you watch completely, then only you will get idea. Okay. So in the periodic classification of elements, why we need to classify the elements, guys? Why we need to classify the elements? Here, for example, in India also, it is classified as so many states. Okay. For example, Tamil Nadu, who are speaking in Tamil, Karnataka, Kannada. Okay. So the state Kerala, Malayalam, like that, they classified, India is classified as different states based on language speaking. Correct. In the same way, we have to classify the elements based on their similarities. Okay, so elements having same similarity, we have to group them together. So like that, we have to classify the elements. For that purpose, so many scientists attempted so many methods for grouping of the elements. Okay, so for example, Lavoisier, Davernier, Newlands, Mendeleev, Henry Moseley. So all these scientists all these scientists have several attempts on this classification of elements. Now we are going to discuss all those. Okay, so it is also very important, guys. I will give short notes, not like a lengthy. Okay, so don't skip the video. So the elements are classified based on the similarities. Okay, note down the elements are classified on the basis of similarities or similar properties. Okay, on the basis of similarities in their properties. Okay, so the arrangements or the arrangement of elements in such a way that grouping of all the elements which have similar properties similar properties called periodic arrangements. Periodic arrangements or periodic classification. Periodic classification. Okay, periodic classification. So scientists have attempted so many. Scientists made several attempts to classify elements. according to their properties. Okay, so the scientists have made several attempts to classify the elements according to their properties. The first scientist is nothing but Lavoisier. The first scientist is nothing but Lavoisier. He classified the elements in two groups. He classified the elements into two groups. What are those? Just metals and non-metals. Okay, just metals and non-metals. So he classified according to Lavoisier. The elements are classified into two groups. One group is only metal. One group is non-metals. Okay, non-metals. So note down the point here. According to Lavoisier, classified elements into metals and non-metals. Okay, after that, the second scientist came into the picture, and this person is nothing but Daber-Neer. Daber-Neer, and that classification is called as trade. So we can commonly call it as Daber-Neer trades. Okay, according to the Daber-Neer, he said he has grouped three elements together. He has grouped three elements together based on their similar properties, and that group of three elements is called as tride. The group of three elements, he called it as tride. So no, don't. He identified that some groups having three elements he defined that some groups having three elements have similar properties. And he called them as trides. Tri means three, na? Called them as trides. Okay, and also he showed that when those three elements are arranged in increasing order, of their atomic masses, Okay, if we arrange all those three elements in the increasing order of their atomic masses, then middle element mass is almost average of remaining two. Okay, that means he said that if we have three elements, let us take 1, 2, 3. If you are grouping them as increasing order of their atomic masses, so increasing order, the middle element atomic mass is almost equal to average of remaining two. Remaining two means 1 plus 3 average, 1 plus 3 average, sum by number. Okay, so 1 plus 3 by 2, so that is 4 by 2, that is equal to 2. So 2 is equal to 2 now. 2 is equal to 2. So he said that when three elements arranged in their increasing order of their atomic masses, the middle element atomic mass is almost twice that of almost average of remaining two. Average of remaining two. So let us take example, then you will get understand. Okay. So here example, let us take lithium atomic mass approximately 6.9 and sodium 23 and potassium 39. So he has grouped these three elements. Okay, and now we are arranging these three elements in the increasing order, correct? Increasing of order of atomic masses, correct? Now, as per this Davarnir, the middle element atomic mass is equal to approximate that of remaining average of remaining two. So average of remaining two means 6.9 means almost 7 plus 39 by 2. So that means approximately you will get 23 only na. 39 plus 7 46, 46 by 2, that is approximately 23. So like that he has grouped the elements in the 3. Okay. So here the very important question you will get. Here Davarnir arranged the three elements in the increasing order and he called them as dash. So he called them as trades. Okay, our trade theory is given by which scientist? Trade theory is given by which scientist? That is Davarnir. So like that questions we are getting. Okay. All of you clear? It is a very simple but somewhat of boring. Okay. Somewhat of boring, but we have to understand. Very simple thing. Okay, first of all, Lavoisier said that the elements is classified into just two, that is metals and non-metals. But Davarnir, three elements are grouped together. Okay, here you will get the question like, which scientist classified the elements just metals and non-metals? That is nothing but Lavoisier, like that. Okay, coming to the next one, third one, Newlands. And Newlands, the scientist, proposed the theory called as law of octaves. So Newlands law of octaves or octave theory. Octave theory is given by the scientist Newlands. That is the very important thing. Okay. So note down here. Here Newlands also grouped the elements together, but it has taken 8 elements. He grouped 8 elements in the increasing of atomic masses. Then every 8th element is similar properties to the first element. Every 8th element is similar property to the first element, like music, sarigamapa. Okay, sarigamapa, the ni. 8th one again sa you will get. Okay, so 8th element, first element, both you will get sa. So like that he has grouped the elements into 8. Okay, note down. According to Newlands, don't worry, after this I will do the small tricks to remember. Okay, first of all we have to learn the subject and we have to make trick also. According to Newlands, when elements are arranged in increasing order of atomic masses, then every 8th element every eighth element has similar properties to the first, just like music, like musical notes. Okay, you know very well musical notes. Here sa, re, ga, ma, fa, da, ni. So first, second, third, fourth, fifth, sixth, seventh. Again you will get sa only, correct? Again you will get sa. That means eighth one. So eighth element having similar property to the first element. So in the same way, the Newlands arranged the elements in their increasing order of atomic masses in the same manner. Okay. For example, he has given hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen. After that, eighth element again, Sa. Again Sa means here we will have the Sa here, eighth element. So that eighth element here, fluorine, sodium, magnesium, aluminum, silicon, phosphorus, sulfur. So that means Sa is similar to Sa. So in the same way, hydrogen and fluorine having same properties, same, both are non-metals. Here according to Re, here also next one after Sa you will get Re only na. So here lithium and sodium, those are metals. So like that he has grouped the 8 elements together and he named that as law of octaves. Law of octaves. Here you will get a question like according to Newland's octave theory, every eighth element is similar to which element? That is nothing but first element. Every eighth element is similar to first element. Okay. And in the same way, every 10th element is similar to, this is the 8, that is 7. Here 8. It is again 9. It is again 10, 11, 12, 13, 14. So that means every 10th element is similar to third element. Every 11th element is similar to fourth element. Like that also you will get the question. Okay, all these are previous questions. Okay, so don't worry, we will also practice the MCQs. In that you will get the idea how the questions will be framed. Okay, so up to now every 8th element is similar to first element. 9th element is similar to second element. 10th element is similar to third element. Like that he has grouped the elements together. Okay, all of you getting my point? Okay, and one more important point in this Newland's octave theory. This Newland's proposal applicable up to calcium only. Very important. Up to calcium only. Calcium atomic mass is 40. Okay. So very important question here. This Newland's octave theory is applicable up to calcium only. After that, what will happen? After that, it fails. After that, it fails. Very important point. Okay. And one more important question in this Newland's octave theory. At the time of Newland's octave theory, how many elements are introduced? How many elements are available? Okay. So at the time of Newland's octave theory, 56 elements only available. remaining not discovered. Okay, so note down that point. Newlands assumed that only 56 elements existed in nature. But after that, so many elements are introduced. Okay, but several new elements discovered. So this proposal also failed. So it is also failed. Okay, it is also failed. Once again, guys, first one, the scientist Lavoisier made the classification just metal and non-metal. After that, Daubernier entered and he said that he has grouped three elements together. After that, Newlands came. No. Elements are not grouped 2 or 3. These are grouped 8. Like musical notes. Saregama Padani. Okay, every 8th element is similar to first element. 9th element, second element. 10th element is similar to third element. Like that he has proposed. Up to Newlands, that is at the time of Newlands active theory, only 56 elements are existed, and this proposal is valid up to calcium only. Okay, calcium only. So we have tried to make a small trick to remember. First one, if you can consider all the elements are divided into just metal and non-metal. Metal and non-metal. Okay, that is given by which scientist, guys? There is a love between metals and non-metals, na, male female. Okay, so as the name of love, the scientist is called as Lavoisier. You can remember like that. Okay, there is a love exists between only two, that is metals and non-metals. That scientist is name is Lavoisier. After that, the another scientist came na. Who is that scientist? Daubernier. He has given traits. Triangle love story. He has given triangle love story. Okay, triangle love story. According to this triangle love story, three elements are grouped together. Three elements are grouped together. And third scientist, who is the third scientist? Name Newlands. As a name itself, it is a new land, a different land. Okay, in that land, the elements are, there is a love in the elements is not like a 2, not like a 3. 8 elements are grouped together. 8 elements are grouped together. And in that, every 8th element is similar to first element. If you arrange all the 8 in the increasing order of their atomic masses, 8th is similar to first, 9th is similar to second, 10th is similar to third, like that. Okay, so there is a love between just metals and non-metals that is given by Lavoisier and traits. Daubernier, Newlands, octave theory. New land, that is a different land. Okay, so in that 8 elements are grouped together, octave theory. Okay, now you can easily remember. After this, one more person came into the picture. That scientist is nothing but Mendeleev. The Mendeleev said that it is not like a grouped together as 2 or 3 or 8. We have to arrange the elements in a tabular manner, like rows and columns. Okay, so we have to group all the elements like tables. Okay, rows and columns. But he just given as tables and columns means he may not get famous. Correct. So that's why Mendeleev given the names for those rows and columns. Rows are called, columns are called. Okay, like that. Then he get benefited. And he is, and general people think that, oh, he is very famous, he is great. Okay, so he said horizontal lines as periods, vertical lines as groups, like that. Okay, we have to take that one also. The next scientist, Mendeleev or Mendeleev's periodic table. Periodic table. Okay, so he has arranged the elements in the form of rows and columns, and he called that as periodic table. So that's why he called as father of periodic table. Very important question. Father of periodic table is nothing but Mendeleev. Very important question for any type of examination. Okay. Father of periodic table is Mendeleev, Dmitry Mendeleev. Okay. And he arranged the elements. Note on the point. He arranged the elements on the basis of fundamental property, that is atomic mass. Of atomic mass, that is nothing but which order? Increasing order only. On the basis of atomic masses, and also similarity of chemical properties. Okay, in his periodic table, in his periodic table, horizontal lines called as periods. The second one, vertical lines called as groups. Okay, this Mendeleev is very clever na. He has seen Three Idiots movie before release. Uh, you know very well, in the Three Idiots movie, one small scene is there. The professor asking that what is a machine. Uh, Amir Khan said that which reduces the human effort. That means he has given the answer in a simplified manner, very simple manner, very easy understandable manner. Then the professor said that it is not correct, like that. Correct. Then one more person will give the definition that is available in the books, very lengthy definition. And professor said that that is a perfect. So in the same manner, if we have given any in a simplified manner, that may not be recognizable. We may not get the credit. Okay, that is the easy thing. There is no credit for you. Like that, we are getting the response. Okay, so that's why this Mendeleev is very clever, and he complicated simply things into a complex, like horizontal lines as periods, vertical lines as groups, and he grouped all the elements into 7 periods, 7 periods, and 9 groups. 9 groups. Okay, so very important question, guys. Who is the father of periodic table? That is Mendeleev. The second question, as per the Mendeleev, horizontal lines are called as dash, vertical lines are called as dash. So many students have confusion on these two. So you have to make a small trick to remember. What is a small trick to remember? Horizontal periods. Okay, horizontal periods. Just remember this one. If you remember horizontal period, vertical is groups. The remaining is vertical groups only now. So for this you have to make a small trick. HP petrol, HP laptop, horsepower. So you can easily remember the HP petrol or HP laptop or horsepower. H for horizontal, P for period. So horizontal lines are called as periods. So the horizontal lines are periods, vertical lines are groups only. No need to remember. Okay. So make a small trick to remember that one. So according to this Mendeleev, how many periods and how many groups are there? 7 and 9 only. So total how many elements? Total 63 elements only exist at the time of Mendeleev. 63 elements only at the time of Mendeleev. That is also very important. At the time of Mendeleev, how many elements are existed? That is 63 elements only. So note down the point. Very important point. In this periodic table, in his periodic table, that is Mendeleev periodic table, periods are 7, groups are 9. Okay. After that, so many elements are introduced, and Mendeleev not given hydrogen place, and he has not given about isotopes. Okay, so after this, one more periodic table came into the picture. That is nothing but Henry Moseley principle. Henry Moseley principle. Up to that Henry Moseley, all the classification is based on atomic mass. If you can consider Mendeleev, that is based on atomic mass. Here Davernier based on atomic mass. Okay, and here Lavoisier based on atomic mass. So here up to the Moseley, the classification is mainly based upon the atomic masses. But this Henry Moseley is the scientist, new scientist, Henry Moseley. Is Henry Moseley discovered that there is another property is there. That property is perfect for classification of elements. That property is nothing but atomic number. Atomic number. Okay, so he has given the classification based on atomic number. That periodic table is called as modern periodic table or new periodic table. Okay, so note down the point. In 1930, Henry Moseley showed that atomic number of element is a more fundamental quantity or more fundamental property than its atomic mass. Okay, so modern periodic table classification based on atomic mass. Okay, according to Henry Moseley or modern periodic table, the classification is based on atomic number. Atomic number. Atomic number. Okay, so modern periodic table classification is based on atomic number. So in this modern periodic table, according to modern or Mosley periodic table. How many periods we have? The periods are 7. There is no change in the periods. But coming to the groups, how many groups we have? Previously we have 9 groups only. According to Mendel, if he is asking 9 groups only. If they are asking according to Mosley, the groups are 18 groups. 18 groups. Okay, so that means the periods means horizontal. We know very well. Groups means vertical. Vertical. Okay. Groups means vertical. So before Mosley, all the classification is based on atomic masses, but Mosley discovered or showed that atomic number is a fundamental property than atomic mass. So the classification has to be based on atomic number only. So we have followed this one and grouped the elements into 7 periods and 18 groups. Okay. Now coming to this is the periodic table and we will discuss the remaining points also, no need of worry. Okay, so just I am giving briefly in this. Here, this is the horizontal line, hydrogen to helium, and this is the second horizontal line, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So like that, first period, second period, third period, fourth period, fifth period, sixth period, seventh period. So how many periods are there? 7 periods. And what about the groups? First group, second group, vertical lines are groups. Third group, fourth group, like that we have 18th groups. So total 7 periods, 18 groups in this modern periodic table, that is Henry Moseley periodic table. Moseley or modern periodic table. Okay. The next session we will discuss about what are the metals and non-metals, what are the lanthanoid series, actinoid series, what is the S black, B black, okay, S, P, D, F, blocks, all those we will discuss, and important terms like atomic size, ionization energy, electron affinity, and how the electron affinity changes in the groups, how the electron affinity changes in the periods, like that. Okay, now up to this the most important questions are here. The theory classified just metals and non-metals is by Lavoisier, trade theory by D'Abernin, octave theory by Newlands. Okay, he is the father of periodic table, Mendeleev. According to Mendeleev periodic table, how many periods and how many groups? Horizontal lines are called as dash, vertical lines are called as dash. And who discovered atomic number? That is Moseley. And modern periodic table classification is based on atomic number and periods and groups. Okay. Okay, students, we will discuss the remaining in the next session. Okay, I love you. Thank you so much for watching. Take care. Bye, guys. And students, if you like my classes, don't forget to click on like button and also please share the information to all your friends. Thank you so much, guys.